Hello everyone, welcome to Sulfursoft. Today we are going to start lecture number 7 of Python Mega Course. In this lecture, we will discuss what is int data type in Python. The in-depth knowledge of int data type will be delivered in this video. Moreover, we will also discuss different base conversion and how Python gives us flexibility to convert one base to another base very much easily. What are the bases? In mathematics, to represent integral value, there are four bases: decimal base, binary base, hexadecimal base, and octal base. We will also discuss all these bases and how these bases could be converted into other base in this video. Whenever a variable is defined with the whole number, then data type of that variable will be integer. Let's see on the pie chart. Let's suppose we have a variable alpha is equal to 10. In other languages, you need to specify int before the variable so that you could be able to tell that this is integer value. But in Python, this is not the case. You don't need to define any int before the variable name. This value, this is the value which will define the data type of this variable. If it is whole number, then data type will be integer. If it is any other float number or any string, then data type of that variable will be according to the value. So in Python, value decides the data type of variable. I am printing the type function to check the type of this alpha variable. I have already discussed this type function in the previous videos. If you don't know about this type function, then please go to the previous videos and see what this type function do or what is the purpose of this type function. So I am writing, let's check the type of alpha. Here you can clearly see that type of the alpha is integer. It belongs to integer class because alpha is assigned a whole number value, and this value is defining the type of variable. There are two versions of Python, Python 2 and Python 3. Python 3 is in active development while Python 2 has no support of development now. If we want to define a variable with a large integral value, then in Python 2 you need to specify a long keyword before the variable name to show that it is a large integral value. But in Python 3 there is no such keyword of long. Python 3 gives us the flexibility to use only the variable name, and you can define any length of integral value, and you don't need to define any long keyword before the variable. Python virtual machine will itself convert the value into long or short, so programmer don't need to define any long or short keyword before the variable name. Let's discuss on the pie chart. For example, if I would be using Python 2 version, then I will use long alpha like this to represent a very much long value of integer or very much larger value of integer or whole number. Look at here, PyCharm is giving error because we have installed Python 3 and there is no such keyword of long in Python 3. That is why the PyCharm is giving us the error. If I'll remove this and if I'll print the value of alpha, then it is giving me the value of alpha. If it would be Python 2, then there would be an error that this value is too much large. You need to define a long keyword before the variable to show that this is the large value. As already described in the start of video, that Python gives us the flexibility to convert one base form to another base form. In mathematics, Integral value can be represented into four base form: decimal form or base 10, binary form or also called base 2 form, octal form or also called base 8 form, hexadecimal form or also called base 16 form. So let's discuss all these with examples on the pie chart. Before going forward, I want to discuss another important point. Whenever we use the print function and print the value of that integral, whether it is in binary, whether it is in octal, whether it is in hexadecimal, it will give the end result into the decimal form. We will also see this on the pie chart. For example, we have an integral value or whole number value that is 10. By default, in Python, the value is defined in decimal form or base 10 form. Now we will discuss how to define binary, how to define octal, or how to define hexadecimal digits or integral values in the Python. First, I will define the binary values. For example, I am defining a alpha binary variable. If you want to define a binary value in the Python, you need to put as 0 small b or 0 capital B as the prefix of the value. As we already know that binary value is in the form of 010101, so only 0 or 1 digit can be used to define a binary value. Like this, I am taking all 1. As I already told you that we can also define the binary value in Python with the prefix 0 capital B. Let's discuss that example as well. I am taking the name as alpha binary capital 0B1111. Let's suppose we are doing this. Now I want to define an octal value. If I want to define an octal value, then I will use 0 O small o or 0 O capital O as a prefix of the value. And the octal value can be taken from 1 to 7, as you already know in the mathematics. So I will define octal value in the Python now. Alpha oct 0 O 1 2 3 for example. Similarly, alpha oct capital 0 O 1 2 3. Here is the small o. Here we have used small o, and here we have used capital O to define the octal value. Let's move forward toward defining the hexadecimal value. Hexadecimal value in Python is defined with the prefix 0x small or 0x capital. Both can be used to define hexadecimal value. For hex 0x. Hexadecimal value can be defined from A to F and 0 to 16. So I am taking as ACE for example. Now I am taking as alpha hex capital is equal to 0x ACE. So you can define binary value, octa value, and hexadecimal value like this. Let's print all the values. Alpha binary print alpha binary capital, print alpha oct, print alpha oct capital, print alpha hex, print alpha hex capital. So if we see the output, then output is in the form of decimal. As I already told you, whatever is the base value, when we use the print function to print the value, then internally Python virtual machine convert this value into the decimal form. Python gives us flexibility and different useful functions to convert one base form to another base form. For example, we can convert any base form to binary base form using bin function. Similarly, from other bases, I can convert to octal bases using OCT function, and I can convert from other bases to hexadecimal base by using hex function. Let's discuss this on the pie chart. Let's suppose we have a variable in the decimal form. I want to convert it into hexadecimal, into binary, into octal by using the bin, oct, and hex function. Let's straightforward print this value bin alpha. This is showing binary value of alpha. Similarly, I want to see the oct value of alpha. For example, I am taking this. Oct value is 0, 1, 2. I want to define hex value of alpha like this. So I have converted this whole number into binary, octal, and hex by using function which are given to us by the Python 3. Now let's suppose I'm taking this binary value and I want to convert this binary value to octal and hexadecimal. And similarly, if I want to convert it into decimal form, then I will only use print function because automatically Python virtual machine will convert this value into the decimal form. Let's see the example. Look at it. 10 is the decimal value. This is the octal value. This is the hexa value. Now I want to convert octal value into different bases. This is the octal value and I want to convert it into binary and hexa. Let's see, it is in octal. This will convert it into decimal, this will convert it into binary, this will convert it into hexadecimal. Look at it. Here we have converted all this. Now I'm going to convert hex value into other base form like oct. Look at it. We have converted all the bases into other bases so much easily by using the built-in function of Python 3. Thanks.